Okay, welcome back. This video is on direct and indirect variation. So we're going to start with direct variation. Direct variation is when you can say that one amount is directly variant to another one. Meaning if one thing changes, the other thing changes proportionately, right? So you'll see things that say like y varies directly with or as either one of those words. You'll see both of those. With x or as x. Meaning it changes as x changes or it changes with x's change, right? What that means is that there's some proportionality here. Oops. Y is some multiple of x. We don't know what that multiple is until we do some work, but it's a multiple of x, right? And this is the direct variation formula. Whenever you hear y varies directly with x or y varies directly as x, this formula should pop up, right? So let's walk through a problem that deals with this and see how we play with it. We might have something that says y varies directly as x. You'll have to be given that information, otherwise who knows why, what we're dealing with here. So y varies directly, choose a word, doesn't matter, as x or with x, whatever. Right? If y is 15, when x is, we've got 5, find y when x is 8. Okay? So there's two things going on. There's two scenarios. One is that y has a certain value when x has a certain value, and they want to know what the value of y is when x has a different value. So there's two scenarios. X is 5, y is something, x is 8, y is something else, right? But I can use this first statement. Just looking at that, right, I know that y varies directly as x, and therefore I have y equals k times x. But I also know that y is 15 if x is 5. Plugging in both y and x into this equation, then I can figure out what that constant k is. K is always just some constant. It's the same constant throughout the whole problem. Might be a different constant for another problem, but once I figure out k, I know k, it doesn't change. So if I divide both of these things by 5, I see that k equals 3. Okay? Which tells me then that I have the equation y is 3x. That's specifically how y changes with x. The question though is to then define y when x is 8, so I'm going to plug in 8 into my x here. So I have y equals 3 times 8. And I can do that. 8 times 3 is 24. And I'm done. That is what y is when x is 8. Right? Right. Let's do another one of these. And in fact, I don't have to erase a lot here because these problems, word-wise, don't change very much. I just have to change those values, right? If y is, let's say, 24, when x is 6, find y when x is, let's say, 9. Right? So again, I'm going to start with my first statement, right? Well, actually, I'm going to start with the fact that y varies directly as x. So this tells me that I'm dealing with this equation, y equals k times x. The second statement here tells me that I can plug in some information. Y is 24 when x is 6. And so if I divide each side by 6, right, then I get 4 is equal to k. And then this third, the question here, find y when x is 9. Well, if k is 4, I know that I'm dealing with this equation. And if x is 9, then y is 4 times 9, or y is 36. That's a direct variation, right? Let's take a look at indirect variation. There's two words that they might refer to this as: indirect or inverse. Inverse variation. Y varies indirectly, or y varies inversely as x, right? And that's what you'll see. And again, as or with x, right? But these two, inverse or indirect, they're your key to know that we're dealing with this formula. It's still y equals k, but instead of being multiplied by x, it's divided by x. Right? X is now in the denominator. So this is the formula for indirect or inverse variation. So let's see how one of these works. Play with a couple problems. Let's say y varies indirectly as x. Okay. If y is 8 when x is 2. Find the value of y when x is 8. Okay. So again, this very first statement here, y varies indirectly with x, that tells us that we're dealing with y equals k over x. Okay. So it's important to know, read that very first one, if it says directly with x, it's y equals k times x, but if it's indirectly or inversely, then it is k over x, right? Using the second one here, that tells me that y is equal to 8, so I'm going to replace y with 8, as long as I replace x with 2. I can solve for k here by multiplying both sides by 2, and here I find that k is 16, which tells me that my equation is specifically y equals 16 over x, because I know k now. And so the third statement here, find y when x is 8. Well, y is 16 divided by x, but if x is 8, then y is 2. And we're done. Let's take a look at one more of those, because I know we want to, right? Again, most of these questions are don't change a whole lot, the wording to start, right? But y varies indirectly with x. If, let's say, y is 4 when x is 7. Find y when x is 14. Okay. So again, I know it's an indirect variation, so I have y equals k over x. But I specifically know that y is equal to 4 when x is 7. So I multiply both sides by 7 to solve for k. K is 28. Therefore, I specifically know that my equation is y equals 28 over x. The question is to find y when x is 14, so I replace my x with 14. And y is 2. And then the last little bit in this section is general solving. Sometimes you'll come across a formula and maybe it's solved for g, but I don't want that. I want to maybe solve it for b, right? So we're going to use all of the addition principle and the multiplication principle in order to solve for b, but where I don't necessarily have a bunch of numbers, I just have variables. I have a bunch of variables, right? So that's this, solve this equation where we said we want to solve it for b. But I can still use those principles. I can still use the addition principle to subtract 2y from both sides. So I will. If I minus 2y, minus 2y. What happens here though is that the 2y cancels on the left, leaving me with rb. And I have g minus 2y, which I can't combine because they're not like terms. So I just write it as g minus 2y. I can't combine them, so I don't. Don't try to combine these. You can't. But if I want to solve for b, I would divide away the other number, which just happens to be a variable r. And so I can still divide everything by r. None of this actually computes because I don't know these numbers. They could change, and therefore all I can say is that b has been isolated, and that's exactly what I wanted to happen, is to isolate b. The rest of this junk over here is my solution. G minus 2y over r, whatever g, y, and r might end up being. Let's take a look at another one of those. Let's say I have a pretty standard one is standard form of a line. Ax plus by equals c. And let's solve this for, it doesn't matter, let's solve it for x, right? And it'll be very similar to what we just did. I want to get this x term by itself, so I'm going to use the addition principle to subtract by from both sides. It eliminates that whole term from the left, and I'm left with ax. I can't combine these terms, so I just write them as c minus by. I want to solve for x, so I would divide a. And I'm done. X has been isolated, it's solved for it. And this expression on the other side is the equivalent statement for x. Okay. All right, that wraps up 1.6. I'll see you guys again for 1.7.